From ContainerDays Hamburg, this video is proudly presented by Dax IT.
So I wanted to check with the audience, how many of you have heard already about virtual clusters? Okay. How many of you are using them? Okay, fantastic. So yeah, this is going to be a great refresher for those of you who are already using virtual clusters, and for those of you who haven't tried them yet, it's going to be a nice adventure of discovery. So I was already introduced, but let me just spend a few words about my background. So I am an open source developer. That's what I've been doing for most of my career. I've been contributing to several open source communities. Between them, OpenStack. I was a co-reviewer for Neutron, the networking project. I was also a member of the technical steering committee for OPNAV. OPNAV actually was a project, because it doesn't exist anymore, was an open source project that focused on network function virtualization, and now it got absorbed by the Linux Foundation networking. I was also a member of the technical advisory committee for the Linux Foundation networking. So as you can see, most of my career as developer revolved around virtual networking. I stepped into management years ago, and I'm currently directing one of the engineering group within SUSE. Specifically, I'm here today because I've been leading, and I still lead, the team that is in charge of virtual clusters. So I want to start today by defining the problem that we are trying to solve. As you can see, I would say in the last decade, the demand in terms of infrastructure has exploded. So if you look back, if I look back at my days, when I was developing something 10 years ago, my laptop was enough. I was writing code there, doing most of the testing there, and I was fine. Now, if you ask a developer, they probably, still write code on their laptop, but they need some on-demand infrastructure to test it. So everybody is using some kind of cloud computing, and this is a demand that is growing. So that's why the problem of efficiently allocating infrastructure is becoming more and more important. So specifically, virtual clusters, what we are trying to solve is, how can we efficiently partition the current infrastructure so that multiple teams can use it without, stepping on each other's feet. It's one of the maybe first solution is basically to use what's already available in Kubernetes, because we do have some constructs that we can use in Kubernetes to isolate different tenants. The straightforward answer is namespaces. So namespaces, if you look at the Kubernetes documentation, they are defined as a way to isolate resources. So in practice, it's a way to partition the Kubernetes API so that you get a different URL for a different tenant. So that if you assign a namespace to a specific team, the team will be able to see only the set of resources that is assigned to the namespace. Of course, that's not enough, because you also need a way to define permissions on those resources. So in Kubernetes, we have airbag that helps with that. So if you use, you can associate airbag rules to a namespace so that you can define which tenant can actually access the resource, modify it, and so on. So that's a way to partition a Kubernetes cluster for different teams. It's not complete isolation, as we will see, because Kubernetes, to be honest, was not built to handle multi-tenancy. It's a flat platform that was built to, quickly spun up the pods and, deploy applications and so on. It was not meant since the beginning to be shared. Something else that we need to solve when we want different tenants to use the same cluster is the problem of noisy neighbor. So you're probably familiar with it, but the idea is that when you have a neighbor that is using a lot of some resource, let's say, for example, using a lot of CPU, then you also pay the consequences. So, for example, it's using a lot of CPU, then also your apps become slower. And to resolve that problem, what we have in vanilla Kubernetes is quotas. So quotas is a set of, a range of resources that can be used by a specific tenant. So it cannot use more than that. So if you take these three construct namespaces, RBAC, and quotas, you do get some kind of isolation in Kubernetes. But it's you have to do it yourself. So it's a kind of a puzzle. That's why I put the puzzle picture there. So you have to figure out what works for you. You have to configure and maintain it yourself. So it's not straightforward, I would say. There are other limitations. So for example, there's no I/O isolation. Because yes, you can assign a resource to a namespace, but not all resources. There are resources that are global. So for example, storage is global, so you cannot partition them with namespaces. So the I/O cannot be isolated. Another thing that cannot be isolated is the network. So you can use network policies to define who has access to a specific network, but the underlying bandwidth, you cannot partition that because that's shared. So again, if you have a noisy neighbor who's using most of the network, then you'll pay the consequences. And then we have the last point that is probably the most impactful in having then the idea of creating virtual clusters, which is now conflicting CRDs are allowed in the same cluster. So CRDs are custom resource definitions, and it's a way to extend the Kubernetes API. They have a version, and you can't have CRDs with different versions on the same cluster. So if you have, for example, developer teams that are using the same CRD, but they want to try different version for some testing purpose, for example, you cannot do that on the same cluster. Another possible solution, to kind of allocate resources to different teams is actually to have a dedicated cluster per tenant. If we go with the metaphor that you see here in the picture, a house is a cluster, and you basically assign a house to every tenant. That's actually great. This is what I would like to have as a tenant, because you get, all the isolation and, a big amount of resources just for you. But of course, it has drawbacks. So first of all, it's very expensive. So creating a cluster and allocating a cluster to a single tenant is a kind of waste of resources. It's not really efficient because, I don't think a team would completely use a cluster. Another problem is that it becomes complex to manage in the long run. Like if you have, few teams, it might be okay. But if you have like tens of teams, you will end up managing tens of clusters, which is, not really easy to do, as some of you might have tried. And also, that depends on, the procurement process that you have. But, generally, it's not that easy to have a cluster. So, of course, that slows down the whole thing. That's why the community was looking for alternative solutions. And that's why virtual cluster came up as an idea. So the idea in itself, it's not really new. It's like, you have a physical cluster that we will call host cluster. And if you go with the same metaphor, this is the house that I'm showing. And then the idea is to partition it in several flats, and those are the virtual clusters. So every virtual cluster has their own rules, so they are airbag, and they also have their own front door, because they have a different API server. And under the host cluster, so we call the host cluster the cluster that is partitioned into virtual clusters. So the host cluster takes care of the core resources. So the plumbing, electricity, so basically networking, storage, and so on. There are now more and more implementation of virtual clusters, but they do follow two patterns, if we want to summarize. One is the nested pattern, which is probably the complex one, at least to what happened? Oh, OK. But if you go with the idea, so for example, if you think at a nested VM, it's a VM inside a VM, right? So the nested approach is basically Kubernetes inside Kubernetes. So what it does, you have the control plane of the virtual cluster. And by control plane, I mean the scheduler, etcd, the controller, and so on. You have the control plane that is running as a pod in the host cluster. So this control plane is actually another instance of Kubernetes. It's a nested instance of Kubernetes. And then you have the workloads of the virtual clusters that are running as pods of this nested Kubernetes instance. So if you go again with the metaphor of the building, you basically have the control plane of the virtual cluster that is a flat. And then this flat is, again, partitioned into rooms. And those are the workloads that are basically the pods that are running inside the nested Kubernetes instance. So we will see a diagram later that will explain better. The other approach is what I called control plane as a service. It's probably not a great name, but I couldn't find a better one. And the idea is actually simple, even if it's more difficult to implement. You have, again, the control plane of the virtual cluster that is running as a pod in the host cluster. But then you have the workloads of the virtual clusters that are running as pod on another cluster. So you can have, for example, worker nodes where you schedule those workloads of the virtual clusters. Another possibility that we will see is actually to reflect these workloads into the host cluster. So use the same cluster to run the control plane and the workloads. So I want you to introduce to K3K. K3K is an open source project that does virtual clusters. It's Kubernetes in Kubernetes, because the first approach that was taken by the project is the nested approach. It's open source, so you can find it on GitHub. And I just put here the star history, which, as you can see, has grown over the last year or so, because we've been actively working on it. And we'll see after this talk if we get some more star. Let's see. So K3K has two different modes, and you will see that they will basically resemble the two approaches that I already explained. One mode is called the virtual mode, that is actually the nested mode, right? So in this case, you have the control plane of the virtual cluster that is running as a pod of the host cluster, thus creating a nested Kubernetes instance. And then the workloads of the virtual clusters are actually pods that are running into this nested Kubernetes instance. So this is great for isolation, because it's nested, it's fully isolated. So for example, if a developer wants to test some experimental feature, that's a great way to do that, because it doesn't impact anything else. And it's also good if you require full control over the Kubernetes control plane. The shared mode is the control plane as a service. Basically, you have the control plane of the virtual cluster that is running as a pod of the host cluster Kubernetes. And then you have the workloads of the virtual clusters that are actually reflected on the host cluster. So they run again as pods of the host cluster. And we use for that virtual kubelet. I will explain more in detail later. So this mode is great for developers who just want to run their apps and they don't want to care about Kubernetes internals. It's also great for platform teams that want to keep full control of the infrastructure and have full visibility. And it's also a great way to have access to the global resources. So, for example, GPUs. Now, let's explain more in details how that works. And I do have a pointer. Yes. So you see here the host cluster. And in the host cluster, this is an implementation detail. We have a namespace for each virtual clusters. In this namespace, you have the control plane of the virtual clusters that you can see here in green. So we are, as Kubernetes distro, we are using K3s. And as you can see, we have the server and the workers. Then in a separated namespace, we have the K3k controller. So this is the nested Kubernetes instance. And within this nested Kubernetes, we have as pods the workloads of the virtual cluster. So we have Nginx in this example and my app. This virtual mode is a conformant distro, so it passed the conformant test of the CNCF. Now let's see the shared mode. It looks similar, but there's this big difference. So again, you have the host cluster, then you have a namespace where the virtual cluster control plane is running, and then you have the namespace where the K3k controller is running. If you look at the pod here of the control plane, you see that we don't have workers node. We don't need them because we are not going to schedule any workload on this nested Kubernetes instance. What we have is virtual kubelet. That is basically what we use as agent to reflect any pod that is created here as workload, so Nginx and my app, every pod actually gets reflected back in the host cluster. So the workloads of the virtual clusters, they run as pods of the host cluster itself. So it's a great way to eliminate some of the overhead of the isolation. So now I prepared a few questions just to check if the understanding of virtual or shared mode is good. So, for example, as a developer, you want to test a new Kubernetes feature that's disabled in the host cluster. What kind of mode would you use? Virtual. Yes, virtual mode, because you need isolation from the host cluster. Great. As a platform admin, you want to test and upgrades across different Kubernetes versions with different API behaviors. What would you use? Virtual again, because you want to safely test the upgrade path, so you don't want to impact the other clusters. So as a developer, you want to build a web app, and you want to expose that outside of the virtual cluster. Shared, yes, because you need to be able to expose it. And as a data scientist, I don't know if we have any data scientists here today. Those are... But anyway, as a data scientist, you want to run a Jupyter notebook, and you need access to the cluster's GPU. What would you use? Shared, yes, because you need access to the underlying resources. And as a platform admin, you want to monitor and secure all tenant workloads from a central location. Shared, yes, because you need full visibility on the workloads. Great. And this is the last one. So you are a network engineer, and you want to evaluate a new CNI. So what mode would you use? Virtual, yes, because you need to be able to run a different CNI. So you need a nested Kubernetes instance. OK, now it's time for a demo, which I have a video here. I hope it's big enough. What I will show here is the integration of K3K into Rancher Manager. So that's why you see the Rancher console here. So we have two terminal windows. This one, as you can see from the label, it's the virtual cluster. This one is the host cluster. And this is the Rancher console. So first thing, we are going to log in the Rancher console. And you will see that we have an extension. Yeah, we have an extension for virtual clusters that you can install, and that will enable you to create a new kind of cluster that is the K3K cluster. So here we create a cluster, we pick a name, and then we need to pick the host cluster, so the cluster that is going to be partitioned. And then if K3K is not installed, you can install it automatically. Then you can pick a K3S version. We support 3 versions. And then you pick the mode. We already explained shared versus virtual mode, but you can create clusters picking the right mode that you want here. So once that's done, you can configure the cluster as usual, and then you click Create, and this will create the virtual cluster. So as you can see now, there are lots of pods being created. This is the kind of the control plane for the virtual cluster that is being created, and we can also see that on the console. This is the node, the host cluster, and these are the pods that are being created. And we fast forward a bit. It takes 1 minute or so to create everything. And now you can see this is the virtual cluster. So you can see it's like a normal cluster that is just on displayed. Now this is the kubeconfig. Let's just export it so we are in the virtual cluster. Now let's get the nodes of the virtual cluster to check the Kubernetes version. And as you can see, we have a different version in the host clusters. So the virtual cluster is running a different Kubernetes version. So now we want to create an app in the virtual cluster. So let's install Nginx as ingress. OK, now let's have a very simple app. You see the YAML here, nothing fancy, just volume, deployment, a service, and an ingress. It's a very simple one. Let's deploy it. Great. Now this is deployed. Let's get the services so that we can get the IP. So this is the port that the application is using. Now let's go to the browser. OK, the application is working. So it was exposed because we are using a share mode here. So now let's look at the CRDs on the host cluster. As you can see, there's a bunch of them. Now what we will show is that you can have different CRDs on the host cluster and on the virtual cluster. So to show that, we will install kubewarden on the virtual cluster. Kubewarden is a policy engine that has few CRDs. So we are going to install them. This is being done. As you can see, nothing has changed on the host cluster. So we install kubewarden on the virtual cluster. We have the kubewarden CRDs on the virtual clusters, but they were not reflected in the host cluster. So it's completely isolated. So this is all I wanted to show as a demo. Now let's go back to the slides And let's recap. So a quick wrap up. When using virtual clusters, you do have lots of benefits. So the first one is cost saving, because of course you cut the cost of the infrastructure because you use the infrastructure more efficiently. It's also quick to provision, and you can also automate that. It's simplified management, especially compared to do-it-yourself solution. You have a centralized place where you can control all your virtual clusters. It also offers stronger isolation compared to namespaces. There are trade-offs, of course. It's a new abstraction, so it requires some learning. It's also not super straightforward to debug, to be honest. It's an emerging space, so there are lots of solutions right now, but none of them is super mature. So it's a space that still needs some time to become stable. And it's also not really a substitute for hard boundaries. Like if you have very strict security requirement, it might not be the solution for you because you might have to have dedicated infrastructure. If you think it's right for you, you can actually have a look in GitHub and try now K3K. As said, it's open source, so everybody can try it. SUSE has a booth here, so if you want to discuss further about virtual clusters or whatever, we would be happy to have you at our booth, so come and visit. And that's actually all from me, so I'm waiting to get your questions.
Can virtual mode workloads span across multiple parent K8s nodes? If so, how?
Yeah, so you can have multiple nodes, of course. If the cluster has multiple nodes assigned, yes. And it works, so it's a distributed infrastructure. So even the control plane is distributed, it's a pod. So in my graph, I was showing kind of one instance, but of course, this gets replicated in all the nodes.
How does K3K compare with vCluster?
Yeah, that's a great question. That's like a business question or something. So technically, K3K, so especially the shared mode is very similar to what vCluster does. But vCluster, they don't specifically have a virtual mode. They are developing what they call a vNode, which is something similar, but to my knowledge, it's not done yet. So, yeah.
Is the K3K project intended to be used in hard multi-tenancy architecture, where their tenants are possibly hostile?
Yeah, that's a tricky question. It depends on your requirements. So if it's really hard multi-tenancy, I wouldn't go with virtual clusters, to be honest. Because yes, you have isolation, but it's not compared to the isolation that you can have when you have a dedicated infrastructure. So if you have hostile tenants, I would personally dedicate physical nodes to different tenants.
So the next question is 2-in-1. Can you manage K3K via Terraform? And can you have updates of the version of existing virtual clusters?
Yes, you can use Terraform, of course. And yes, you can upgrades. So we are still not there because I haven't said that actually. So K3K is, as I was saying, is the open source project. It's integrated into Rancher Manager. It's still not available for the general public. Right now, it's a tech preview, but it's going to be available in November. So starting from November, we will actually start managing upgrades. Because once we support a version, of course, we need to support the upgrade path.
Is K3K GitOps manageable?
Yes. It depends on you. Of course, you have to come up with your scripts.
And does SUSE offer support for K3K?
Yes, it does, because it's, as I was saying, it's integrated into Rancher Manager. So from November, you can have K3K fully supported by SUSE.
How does it solve the noisy neighbor problem?
Yeah, it doesn't solve it completely, because as I was explaining, you have global resources that cannot be really partitioned. So in a case of like network bandwidth, it won't help, to be honest. But in other cases, with a combination of quotas and virtual clusters, you can actually at least mitigate the noisy neighbor problem.
How's the networking implemented for the virtual clusters?
Yeah, that's a great question. So it depends on the mode. If you go with the virtual mode, you get a completely different CNI. So you can have whatever you like, I don't know, Multus on the host cluster, and then have Cilium on the virtual cluster. So it's completely separated. While with the virtual mode, you basically inherit the CNI of the host cluster.
Okay, they're jumping around the questions because people are upvoting them. So,
Yeah, okay.
Difference between K3K and Kubernetes approach to cluster and cluster.
Yeah, it's a bit tricky when you ask me about differences, because yeah, of course I'm biased. I would say the approach is similar with the virtual mode. I don't know exactly how they implement it, because I didn't look at the code.
Okay, how deep can it go? Can you make virtual clusters within virtual clusters?
Yeah, it's a matrix. It's same as nested VM. You can have as many levels as you want, but at some point it will stop working. Yeah.
What do you think about the vCluster project, and do you also have a paid plan, as they block a few features unless paid version?
Yeah, so luckily I work for SUSE, which is an open source company, so our strategy is different from commercial or common commercial company. So what we do is the source code is a variable, so you can have a look and you can deploy it. What you pay when you buy a SUSE product is the support. So we support you, and also we kind of give you releases of the products, and we support upgrades and so on. But the source code is a variable. So if you're good and you want to do it yourself, it's possible.
What kind of containers does it leverage, and can it run in vanilla Kubernetes?
You mean virtual clusters? Any kind of containers? Can you run in a vanilla Kubernetes? Yes. I guess the question was because I showed that we are using K3S. We are using K3S just because it's a lightweight distro. So K3K under the hood is using K3S. If you want to switch to any other Kubernetes distro, it's possible, but you have to code it yourself. So you can send a pull request to the K3K repo and do it.
Do you also have a vision of migrating virtual clusters from one physical host to other physical hosts during DR scenarios?
Yeah, it's possible. So virtual clusters are, so they should behave as normal clusters. So it should be possible to migrate them. It's not a scenario that we tested, to be honest. So probably we'll need to fix some bug here and there, but it's a possibility.
Oh god, it's jumping around again. Am I able to bind virtual cluster pods to specific host cluster nodes?
Not yet. That's not a variable. We could work at that, but right now you cannot do that.
Next one is, which Rancher version is needed for K3K, like in the demo?
Okay. Yeah, so what I showed in the demo is a kind of a tech preview, but it's going to be available for 2.14, so in November.
What is the advantage of a vClusters? I think we kind of had several questions like this one.
Yeah, so it's you have both modes with K3K, right? I think with vCluster, you have vCluster and vCluster Pro. And so K3K is fully open source.
What would be a production use case be?
Oh yeah, it's for example, if you have you are a cloud provider and you want to utilize your infrastructure, so you want to divide a cluster for several tenants. So they pay you for whatever workloads, and under the hood, you use virtual clusters.
Thank you so much.
Yeah, great. Thanks a lot,
This has been
everybody.
all of the questions.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.